Determinants part 8. Today we will see adjoint of a matrix. Adjoint of a matrix. Adjoint of a matrix is denoted by, we used to write ADJ. A small, DJ all small. Adjoint of a matrix A is nothing but the transpose of a, it is the transpose of a matrix of cofactors. That means we have to write the matrix of cofactors. What is the matrix of cofactor? We used to denote by C cofactor, so we can say that transpose of matrix of cofactor means C11, C12. You have to find the cofactors and write in the matrix from C21, C22, C23, C31, C32, and C33. This is the matrix of cofactor, and its transpose will be the adjoint. Okay, got it? So its transpose, what will be its transpose? Transpose means first row will become first column. When you change rows into column, it is called its transpose. So we can say C11, its transpose will be C11, C12, C13, C21, C22, C23. Okay, C31, C32, and C33 is the transpose of this matrix of cofactors. So obviously, it is showing that we have to find the cofactors of all elements and write its matrix and find its transpose. Or we can directly write C11 instead of writing C11 here. C11, 12, 13, 21, 22, 23, 31, 32, 33 is the adjoint. It can be 2 by 2, 3 by 3, depends. Okay. So now you will take one question of 3 by 3. Find the adjoint of. Find the adjoint of. Find the adjoint of the matrix 1 minus 1, 2, 2, 3, 5, and minus 2, 0, 1. Find the adjoint of the matrix this. So as you know, we have to find C11, C12. First we will find what? C11. C11 is minus 1 raised to power 2. C11 is this 3, 5, 0, 1. So 3 1 to 3 minus 5. So 3 is the answer, C11. Similarly, C12 will be equal to minus 1 raised to power 3. So negative sign will come outside. I am writing directly 2 1 to 2 and minus minus plus 5 2 is 10. So this will be minus 12. Okay, C12. Similarly, C13. C13 means this is C13. This row and this row is deleted. Multiply this with and minus 1 raised to power 4 means positive. And 2 into 0 is 0, then minus, and this minus will become plus. 2 3s are 6. Similarly, C21 is minus 1 raised to power 3, so minus negative sign will come outside and then multiply. C21 is this is in this row and this column, so minus 1 into 1 minus 1 and minus 0 into 2 0, so minus minus plus 1. C22 is this one, this is in this row and this column, so after deleting it we get minus 1 raised to power 4, 2 plus 2 4, so positive, and 1 into 1 1 minus minus plus 2 to the 4, 4 plus 1 5. C33 C33 is this sorry 23 C23 is this number, this is in this row and this column, 1 into 0 and minus 1 raised to power 5. 5 means negative power, negative value, and 1 into 0, 1 into 0 0 and minus, this is also minus. So minus 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 3 times minus, 2 ones are 2, and this is also negative power 5. So minus minus plus, answer will be 2. Then C31 means this number, okay, and it is in this row and it is in this column, and power will be equal to minus 1 raised to power 4, that is positive value, and minus 1 into 5 minus 5 and minus 3. Minus is there, 3 to the 6, minus 5 minus 6 will be equal to minus 11, 31. Okay, then C32 is this number, this is in this row and in this column, delete 1, multiply with 5, but minus 1 raised to power 3 plus 2 5, that is negative number, and this row this column is deleted, so 1 into 5 5 and minus 2 to the 4, 5 minus 4 1, but outside minus is also there, so the answer will be equal to minus 1. Then C33 is this number, this is in this row and in this column, delete, and minus 1 raised to power 3 plus 3 6, this you have to add, that is positive, and 1 into 3 3 and minus, and this minus will become plus 3, 2 ones are 2, this is also plus, so answer is 5. Okay, now it is up to you, either you write directly adjoint A, or you can write first coefficient of cofactor and then its transpose, is up to you. So generally we are denoting C dash, C is the coefficient of cofactors. So we can directly write the values. Adjoint A is what? C11, C12, C13, and C21, C22, C23, C31, C C31, C32 and C33. Okay, we can substitute. Can substitute the value now. Or otherwise, if you want to write C11, 12, then you have to put one dash. That is for T is the transpose, and then you can take the transpose. It is up to you. I think you should go by that way. So we will write the values in C11, C12, C13 like that, and transpose, and then we will take the transpose. Because it is very important that you should remember that it is the transpose. Because some questions may be asked like that only. So C11, C12, C13. C11 is 3 transpose of this T. We will put T. For transpose, we can use T or we can use dash. So here better to use T. So T means the transpose of this matrix. 3 C11, 3 C12 minus 12, and C13 is 6. C21, 22, 5, 23, 2. 31 minus 11 minus 1 and 5. And then transpose. Always use it this way. First row will become first column 3 minus 12, 6. Second row 1, 5, 2 will become second column, and third row will become third column. So this is the adjoint of a matrix of order 3 by 3. There are some theorems based on adjoint. If A, theorem number 1. Theorem number 1, if A is any given square matrix, okay, means 2 rows, 2 columns, 3 rows, 3 columns. Then we can multiply determinant A with its adjoint, or first we can write adjoint and then multiply with the matrix, not determinant, sorry. The matrix A multiply with its adjoint A. Adjoint A is also a matrix. These two matrices, or we can find the determinant of that matrix and then multiply with identity matrix. Second, if A and B are non-singular matrices. Non-singular means whose determinant should not be equal to 0. Some value should be there. Then they are non-singular matrices. Then if you multiply that matrix A into B, B into A, they are also non-singular. Okay. AB will also non-singular, means determinant of AB will not be equal to 0, as well as BA, determinant of BA will not equal to 0. This is another theorem. And the third theorem is product or determinant of the product of matrices. This is the product of matrices. A into B is the product of matrices, and its determinant means some value. Determinant is some value. Expanding, getting some value will be equal to the product of the respective determinants. So find the determinant of the matrix A and determinant of the matrix B. Can you multiply these two values, or if you first multiply the matrices and then find its value, it will be same. So these three properties in the question, actually they are asking in the question to show these properties. So I'll write here one question. The question is find the adjoint, find the adjoint of the matrix -1 -2 -2 2 1 -2 2 -2 and 1, and hence show that A into that property, A into adjoint A is equal to determinant of A into I3. I3 to I3. This we have to prove. So coefficient we have to find. So first adjoint. Obviously it is used here also. So adjoint C11, C12, C13. So C11 is -1 raised to power 2, and 1 into 1 minus plus, all 3 minus 4 plus 1 -3. Can I write directly? Are you understanding? C11, C12. Now I'll write direct values. You know that how to find the previous question. You can follow the previous question because we have less time. So -6. C13 will come this one. Then C21, if you will find out, C21 will be 6. C22 you can check. You can do it later on and check the answers. C22, C23 will be equal to -6, and C31 6, C32 -6, and C33 will be 3. Okay, then we will write the adjoint A. Now here I'll write directly adjoint A. C11, C12. So -3, -6, -6. Second row will become second column, 6, 3, -6. Third row will become third column. This is the adjoint A. So now we have to show that adjoint A into adjoint A multiply. So before that, determinant also we need to find determinant also. So find first determinant A is equal to -1, -2, -2, 2, 1, -2, 2, -2, 1. You can use any this diagram, status diagram or values, and then you can get the value as 27. This will come 27. Okay. And right hand side is determinant into I3 that we will show. Before that, add A into adjoint A. Now we will multiply A into adjoint A. So matrix A is given -1, -2, -2, 2, 1, -2, 2, -2, 1, 2, -2, 1. Multiply with adjoint A. Adjoint A is -3, 6, 6, -6, 3, -6, -6, -6, and 3. So first row multiply with first column, first row multiply with second column, first row multiply with first column, -1 into -3, 3, 3 plus 6 2s are 12 plus 12. Then multiply first row second column, -1 into 6, -6, -6, minus plus 12. Then -6 plus 12 -6. Like this, you will get the result as the final result will be 27 Here you will get 27, 0, 0, 0, 27, 0 and 0, 0, 27. And which is equal to A into I. Determinant, if you will multiply determinant A with I, determinant A is what? 27. This is the value. And I is a matrix. So matrix is what? 1, 0, 0, 0, 1, 0, 0, 0, 0, 0, 0, 1, 0, 0, 1. And multiply 27 inside, you get 27, 0, 0, 0, 27, 0 and 0, 0, 27. Therefore, we got the result A into adjoint A is equal to determinant A